All right, we're going to go with binomial probability distributions today. Okay, so basics of a binomial probability distribution. A binomial probability distribution results from a procedure that meets these four requirements. One, the procedure has a fixed number of trials. Okay, so a trial is a single observation. Two, the trials must be independent, meaning that the outcome of the individual trial doesn't affect the probabilities of the other trials. Three, each trial must have all outcomes classified in exactly two categories, commonly referred to as success or failures. Okay? Probability of a success remains the same in all the trials. Okay? So notations for binomial distribution. S and F, so S success and failure, denoted the two possible categories for all outcomes. So the probability of a success is P, okay? The probability of a failure is 1 minus P, or Q. N is a fixed number of trials. X is the specific number of successes in the trial. So if I'm like looking for 5, so X can be any whole number between 0 and N inclusive. P is the probability of success in N trials. Q is the probability of a failure in those trials. And then P of X is the probability of getting exactly X successes among N trials. Example 1, Twitter. When an adult is randomly selected with replacement, so we're going to take an adult, ask them a question, put them back in, and maybe ask them something. There is a 0.85 probability that this person knows what Twitter is, based on results from a Pew Research Center survey. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. Okay? So, does this procedure result in a binomial distribution? Okay, so we're gonna ask that question. So this procedure does satisfy requirements for binomial distribution, right? Is the number of trials fixed? Yes, at 5. 2, 5 trials are independent? Yes, because we have replacement, okay? The independent because the probability of any adult knowing Twitter is not affected by the results of the other selected adults. Each of the 5 trials has 2 category outcomes. The selected person knows or the selected person does not know. The probability is 0.85 probability that the person knows what Twitter is, and that probability remains the same throughout the 5 selected people. Okay, so example 1 continued. If the procedure does result in a binomial distribution, identify the values. Well, what's N? How many trials are we going to have? 5. How many X's are we looking for? How many successes? 3. What's the probability of the success? 0.85. What's the probability of a failure? Well, that's 1 minus 0.85, or 0.15. So, using the binomial probability formula. Okay, so this is the formula. P of X equals N factorial over N minus X factorial times P to the X, Q to the N minus X for X equals 1, 2, 3, all the way out to N. Okay, so remember, X is how many successes we have. N is the trials, X is successes in trials, P is the probability of a success, Q is the probability of a failure. Okay, so we're going to go back to that Twitter example, and we're going to find that probability of selecting 5 people and exactly 3 of them knowing. So my N is 5, my X is 3, so I have 5 factorial over 5 minus 3 factorial times 3 factorial times 0.85 to the third times 0.15 to the 5 minus 3, or second, because that's how many failures I have. So I take this, I multiply it all out, I have 0.138178. That is the probability that exactly 3 people in 5 out of 5 will know that Twitter is. Exactly 3, right? Okay. So example 4, double of a problem. So based on a Harris poll, 60% of adults believe in the devil. Assuming that we randomly select 5 adults using table A1 to find the following. The probability that exactly 3 of the 5 adults believe in the devil. Okay, so here's my table. So here's n equals 5. Here's the probability that 0 of them believe. 1, 2, 3, 4, 5. So I look over here. Here's my probability. 0.346. So, okay, so exactly 3 people believing out of 5 is 0.346. The probability that the number of adults who believe in the devil is at least 2. So now what I'm going to do is I'm going to take the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. So I'm going to add these all together and I get 0.913. All right? Using mean and standard deviation for critical thinking. So mean is mu equals NP. Variance is sigma squared equals NPQ. Standard deviation is the square root of that. So the square root of NPQ. Significantly low values are mu minus 2 sigma, right? We kind of remember this. Significantly high is the addition of those greater than that. Values between them are not significant. Okay? So that's binomial distribution. Binomial distribution, you have to have a set number of trials. You have to be able to have those probabilities. You have to have a set number of successes. Probability for success is going to maintain the same. Probability for failure is going to maintain the same.